Good morning. I want to thank everyone for joining us for today's presentation. My name is George Seidman, West-based Services Manager at Earth Data Northeast, and I'll be the moderator for today's webinar. Today we'll be discussing PFCs in groundwater, including the unique challenges to site characterization and groundwater monitoring that they present. We'll also discuss EDNs and West-based technical services and how they can be applied as solutions to these challenges. Before we get started, I'd like to review a few housekeeping items and let you know how you can interact with us in today's session. I've taken a screenshot here to show you an example of the attendee interface. You should see something that looks like this on your own computer in the upper right corner. If you prefer to get the webinar audio through your phone, look for your audio pane and select the telephone option. That'll give you the dial-in information and the access code. You can ask questions through the questions pane. Just type in your question and hit send. At the end of the presentation, we'll do a Q&A session and address as many questions as we have time for. Do we have any questions before we start? Okay, one last thing before we begin. We'll be giving away an iPad Pro to one of today's attendees. We'll have the drawing and announce the winner following the Q&A session, so make sure to stick around. Let's begin.
Greetings. The purpose of this webinar is to introduce you to the technical portfolio of Earth Data Northeast and West Bay Instruments with particular application to the challenges of site characterization and groundwater monitoring for PFC contamination. We will refer in general to fluorinated compounds or PFCs and also to specific fluorinated compounds of interest known as PFOAs and PFOS. The second section is to identify some unique challenges posed to groundwater investigations by the chemical nature of PFCs and the regulatory limits established for human exposure. The presentation is concluded with a discussion on how Earth Data Northeast portfolio of technology and capabilities, now completely PFC-free, is a particularly applicable solution to the challenges providing high-quality, defensible information to form a solid basis for analysis, design, judgment, and implementation of appropriate measures as may be required on a site-to-site basis. The attention to data defensibility is particularly notable in this environment of regulatory and legal and public concern. PFCs are fluorinated organic chemicals which have been produced commercially for decades. They've been used in hundreds of commercial products, applications, and represent a class of more than 6,000 organic fluorine compounds. Some of these undergo biotransformation or funnel to a set of stable daughter products, PFOS and PFOA. PFOS and PFOA have been extensively studied for their possible human health effects, and both have been identified as contaminants of emerging concern, CFCs. PFOs was internationally classified in 2009 as a persistent organic pollutant. PFCs have general chemical and physical properties of interest when considering characterization and remediation of contaminated groundwater. Low volatility, high solubility, and chemical stability make them persistent in the environment over long periods of time. This persistence leads to their ubiquity. They are literally everywhere one chooses to look, from the ice in the Arctic to the drinking water of the islands of the Pacific. PFC contamination in groundwater has been identified in association with manufacturing facilities, aviation facilities, and the wastewater treatment plant effluent. Since they are chemically stable, PFO and PFOA do not undergo significant degradation reactions under normal environmental conditions. Though PFCs have been extensively studied with respect to human health effects, the state of the science continues to evolve as new information becomes available. Human health effects have been identified in association with very low concentrations of PFS and PFOAs. As recently as May 2016, the EPA issued a provisional health advisory which established a new lower maximum limit of combined PFOS and PFOA concentrations in drinking water of 70 parts per trillion. For comparison, this is about the same as 2 seconds in 1,000 years, or 3 drops of water in Olympics. Regulatory jurisdictions such as state of New Jersey have even smaller for chronic exposure and 10 parts per trillion for specific chemical classification of PFNA. regulatory limits in the 10 to 70 part per trillion range, there is an associated regulatory, analytical, and technical interest to investigate almost vanishingly small groundwater concentrations of PFCs in the range of 100,000 years. For comparison, this is more than 100 times smaller than the conventional practice for testing chlorinated solvents such as TECs in groundwater. In the case of such a small quantity, concern, it is critical that it is used for site task and requires considerable attention to detail and to the site investigation work. In the special work environment in the groundwater, the use of existing approaches and technologies can bring a significant result in appropriate analysis and interpretation of unsound decisions. Industry best practices are established and applied to maintain consistency of quality and approach for best defensibility of resulting data. In general, best applying lessons learned from past experiences, modified as necessary to get site-specific. The desired end result is the same: defendable data, which supports appropriate analysis, which informs simple is better. Earth Data Northeast and West Bay Instruments offer a simple, pragmatic solution to the problem. Unique, completely PFC-free tools, equipment, and technology on the obvious premise that if there is no PFC in the tools, they cannot contribute or affect PFC concentrations in the groundwater. This offering is applicable to all stages of the project lifecycle. The robust, field-proven approach of borehole testing instrumentation brings all the expected data quality and defensibility available from over 35 years of worldwide experience, now in a PFC-free package. The typical best practices for a site investigation are familiar to everyone, but these steps to success bear repeating. In the context of the rigorous requirements of the PFC world, the selection of correct equipment, procedures, and documentation are critical elements for each step. Geophysical logging of the open or cased boreholes provides measurements of subsurface conditions not achievable any other way. Lithological logs provide information on the distribution of geological materials, which can be useful in providing the first estimate of hydraulic conditions and for the correlation of results between boreholes. Image or structural logs provide detail on the presence and distribution of secondary porosity and borehole quality. Hydraulic fluid logs provide estimates of fluid quality, borehole crossflow, and effects of drill fluid invasion. To eliminate the risks of cross-contamination, it is vitally important that the equipment and procedures used in geophysical logging be defensively verified to be PFC-free. Geophysical logs provide the first measurements of the in-situ conditions, which can be used to inform decisions on the next steps of the investigation. Combination logs can be an interpretation resource. Also, cross-plots and multiple individual parameters can yield powerful indications of the groundwater flow conditions not immediately obvious from a single parameter plot. Open hole testing with a stratopacker apparatus is an important step to directly measure the capacity to conduct water of the important layers or sections identified in the borehole by geophysical logging. Again, to eliminate the risk of cross-contamination, it is vitally important that the equipment, materials, and procedures used in stratopacking testing be definitively verified to be PFC-free. This slide compares the West Bay approach to traditional groundwater instrumentation practices. The West Bay system provides the same data from multiple depths within the single borehole as is available with conventional instruments. Benefits of this approach include less drilling, less space required, less time, less waste, less risk of PFC cross-contamination, and less money. with the highest level of embedded QA and QC capability. More importantly though, the West Bay system is not about another way of doing the same thing. It's about doing things better with a proven technology that is PFC free. With the West Bay system, packers are used to divide the hole into discrete, isolated sections. Valve couplings are used for fluid pressure measurements, fluid sampling, and hydraulic testing. Wireline tools access the ports through a central access casing and can be used one at a time or as multiples or strings. The system is completely modular, so these zones can be stacked in a borehole without limit. Whether there's 1 or 10 or 50, they have no effect on the neighboring zones, and component locations can be easily changed up to the moment of installation. The main points of our system include no limit to how many of any one component can be installed in a single well, no permanent tubes or any one component to the various operating configuration, integrity, and validity of data obtained. The result is a robust with serviceable operating instruments providing long-term reliability and dependable results. West-Bay Instruments has been accepted by the EPA across the U.S. for the past 30 years. The EPA has implemented the technology in contaminant hydrology studies ranging from local to basin scale.
We'll now open the webinar to questions from the audience. For today's Q&A session, we have the following technical experts from EDN and West Bay to answer your questions. From EDN, we have Dave Fenimore, President and Senior Hydrogeologist, Marty Kirsch, Vice President of Field Services, and Ryan Beebe, Geophysical Logging Services Manager. From West Bay, we have Dave Larson, Technical Services Manager. Let's begin. Okay, we have a first question. What did you do to make your tooling PFC free? I'll divide that up between the services. For the packer testing, I'll direct it to Marty Kirsch.
Good morning. How did we make our packer testing system PFC free? Well, we went through a process of self-inspecting the system to come up with a list of questions that we had for our manufacturer. We then went to the manufacturer of the various components and worked with them on those components, identified ones that might be containing Teflon, or some of the other compounds of concern, and worked with them on substitutes for those components and began the process of eliminating those with Teflon. That's pretty much it.
For the geophysical logging tools, Ryan, you want to take that?
Thanks, George. Very similar to Marty's response, we did our due diligence in reaching out to each of our vendors, and we identified components of each probe that could potentially contain Teflon, and we're actively having them removed.
Thanks, Ryan. For the West Bay, we'll go to Dave Larson from West Bay.
Thanks, George. West Bay manufactures all of the West Bay system components in-house, and we confirm that no PFCs are used in their manufacture.
Thanks, Dave. Next question. When did West Bay change the Teflon components to be PFC free? Dave, from West Bay, did you want to answer that?
Yeah, sure. Thanks for the question, Larry. Yeah, we have just implemented that change very recently, and it's not yet been used commercially.
Thanks, Dave. Next question we have is, how do we decontaminate our downhole tooling and equipment? I'll divvy this up between the different services again. For packer testing, Marty?
Thanks, George. And again, this response might be the same across the board, but decontamination is a process that is generally spec'd out by the engineering firm that's managing the work. There are some generally acceptable procedures that are involved with the decontamination of many different contaminants. But aside from that, it really does, we follow strictly that which is dictated in the scope of work and the work plan of the engineer. We may suggest something that we've seen performed on other sites that is missing from their SOP, but that's basically it.
Thanks, Marty. Does that answer for geophysical logging? Is that the same answer, Ryan?
Correct.
Thanks. Have any other questions? All right, next we have another question coming in. Next question we have is, how difficult is it to find a source of water that is PFC free? Give this to Dave Fenimore, our data.
Yeah, I'm not really sure what the question involves, whether it's globally or within the context of what we would use for a decontamination process. But, you know, it's an emerging contaminant which is being found very much in public supply wells, and the public water purveyors are scrambling to keep up on their treatment technology. For a decontamination process, we would typically be using a distilled water rinse, which you know, would be a bottled water. I'm not really sure, you know, the context of that question, but I hope I answered it.
Next question we have is, do you have any PFC data for systems installed in the past few years where the equipment may have contributed? I don't believe we do. No, we wouldn't be privy to any sampling results for where the equipment was used. Next question, is there a concern that contaminants can get past the West Bay packers? I'll direct this to Dave Larson at West Bay.
Yes, thanks, George. The built-in QA/QC aspects of the West Bay system can be used to document the effectiveness of sealing of the packers.
Thanks, Dave. And I'll send this to Marty Kurse for our packer testing system so he can respond to the same question.
Well, Dave, you might agree that screening the well after the geophysical logs of the packer test would also help, and that's the purpose of it, to help design the West Bay installation and ensure that there's a good seal around each of the zones targeted.
Thanks, Marty. Question we have is, can we provide contact information for those who can provide quotes for field work? Yeah, there should be some contact information on a slide that just popped up. You can also look at Earth Data's or West Bay's website to respond there as well. Are there any more questions? Okay, if that's it, then we'll wrap things up with that. I want to thank everyone who took the time to join us today, If there's any additional questions that someone might come up with after the fact, after we're done here, you can email the contact information up on the screen now. We'll get to those. Or you can ask questions through the contact info on our websites. Before we go, we're going to have a drawing for the iPad. Got it. And I want to say what we have. Congratulations to Bailey Walters from WSP. We'll be sending you an email so we can get your contact information, and then we'll be sending it out to you shortly. If you would like a copy of the webinar, it's being recorded. We should have that available shortly after we're finished up here. Just send an email to contact. We can get that out to you. Again, I want to thank everyone for being here today. And enjoy the rest of your day.